Welcome everybody. We are finally live for real. My name is Andrew Woodward. Welcome to Aero-Gro Indoor Grower on YouTube, the live show on YouTube. This will be a regularly occurring show every Wednesdays at 8. And today I'm really excited for what we're going to do today. This, as the first part of a three-part series, is really where I wish I had started years ago. I wish YouTube had been a thing. I wish I'd had somewhere to go. And what I want to do is present to you in this three-part series what I wish I would have known when I was getting started. And I broke it down into three parts because there is a lot of information. But if you're just getting started with indoor growing and hydroponics, you're probably overwhelmed with, acronyms and new words and new tools and the whole thing. So I'm hoping to take out some of the mystery and hopefully create a little excitement and a little comfort around the technology. And with that, let's see if this new streaming technology that we're going to be trying out today really does work. I don't know. I spent a couple of days setting it all up. And we'll see how it goes. But you never know, because all the previews in the world, all the testing in the world never really seems to ensure you that everything's going to work. So to start, let me just go over what we're going to be covering today. What does hydroponics, or how does hydroponics compare to soil-based growing? I'll talk about a few different things that you're probably going to want to know about. A lot of it you already do, or you wouldn't be here. You obviously know that hydroponics is a great way to grow. It's less expensive overall. You may or may not know that actually, but I'm sure you know that it's potentially a faster way to grow, cleaner way to grow. I'm sure you know that. But there are some other things you may not be aware of that actually play into how hydroponics works and how we can get better at it. So I'll cover some of that. I'm going to go over what kinds of hydroponic systems are available. There are a dizzying number of ways to deliver nutrients to plants, and we'll go over a few of the main ones that you'll probably run into when you're shopping for equipment, or when you're reading blogs or looking at YouTube videos. We'll go over the systems that you're likely coming across. Where should I set up an indoor hydroponic garden? We'll go over some different possibilities there for in and around your house. What supplies will I need? These are supplies that are what I consider the must-haves. Now, there are obviously nice to haves and there are must-haves in any kind of pursuit and anything that you do. These are the tools that I think really, I wouldn't even want to work daily with this unless I had these tools. So those are the tools I'm going to tell you about. Those are the ones you're probably going to want to get right away if you're just getting started. And trust me, they will make your life easier for sure. Is hydroponics expensive? Well, I'm kind of touching on that as we go. There are cost factors with some of the older technology versus the newer technology when we're talking about light panels and things like that. And I'll go over that as we're going through these. What about lighting? Speaking of lighting, I'll go over some of the possibilities for lighting that you can bring into the house, some of the benefits of LED lighting versus some of the benefits of the other forms of lighting as well versus LED. We'll go over that. How much can I grow? We'll touch on that as we go through. Can I expand a hydroponic system? That'll be something I'll be touching on as we talk about the different systems. Growing herbs and medicinals. This is a very popular question that I get asked a lot. Whenever I mention hydroponics and indoor growing, inevitably somebody wants to know about growing other things indoors. And I will touch on that. There's no reason why we shouldn't touch on that. It's becoming a very, well, I don't know about popular, but a more common pursuit, growing indoors for those purposes. So we'll touch on that. So without further ado, let's see here. It's always a good idea, I think, to review really quickly what it is plants are doing when they photosynthesize. So if you remember from your 8th grade biology class, the plant, when it's in the ground, is going through this entire cycle where it's pulling the nutrients from the soil. You can see in the diagram here, it's pulling the nutrients from the soil, And the sun is behaving as an energy source for the photosynthesis process that happens within the plant. The leaves are acting like little solar panels to suck up the energy from the sun, the photons from the sun. And in this photosynthetic process, they use the minerals from the ground in combination with the energy from the sun to produce glucose, which is what it uses to fuel the cells and to produce the fruits and the flowers and all the other parts of the plant. So this process is happening all the time. Now, you have to have all of these elements present to grow a plant. You have to have the light, you have to have the nutrients, you have to have the plant, obviously, and some space to grow, and you have to have some carbon dioxide, which is the catalyst for the process within the plant. The carbon dioxide has to be there, but it can come from other sources as well. And this is where we start to get into hydroponics, because the soil doesn't have to be there. The carbon dioxide doesn't have to come from ambient air. The light doesn't have to come from the natural sun. So when we replace any of those elements of the photosynthetic process, we are in control of it, and we can predict the behavior of the plants with much greater accuracy than we would be able to if we just planted them outside and let nature do its business. So really what we're talking about here is exactly what you see in this diagram, except we've replaced each of these elements with something synthetic, plainly spoken. The LED panels or the light sources, and in this case, we're not going to be talking about grow medium at all today, because we're talking about hydroponics, but you can actually use a grow medium for heavier plants. Which in a bucket, for example, filled with a grow medium to support that root structure. But there are no nutrients in there other than the ones that you're adding. It's still a liquid nutrient-based system, even if there's a grow medium. Yeah, with that in mind, let's move on to the next slide. Here's where it gets interesting with hydroponics, and this is where we start to differentiate the difference really functionally between growing in soil and growing hydroponically, as far as if you're growing food, the amount of food you're going to grow, how fast you're going to grow. The difference is when a plant is grown in the soil, as you can see from this illustration here, it wants to send its roots out everywhere because it's competing with the plants around it. And it doesn't necessarily know where the water or the nutrients are going to be coming from, so it sends out these roots in a kind of an exploration exercise to find those nutrients. And in nature, obviously it has to fight the plants around it and has to be pretty aggressive with its root growth. And as a consequence of that, very often what you'll find is that plants do not get exactly what they need from the soil around them, particularly if they're just growing wild. But even if they're growing and cultivated and so forth, they don't always necessarily get what they need, and they tend to suffer for that by not growing as tall or as big, not producing as much fruit, not being as healthy. Yeah, there are all kinds of side effects of not getting the nutrients that they need. But the result of that is you have a big root structure in a very small plant. Conversely, with hydroponics, it's very much, I liken it to being in the hospital where they give you an IV to feed you if there's some reason why you can't eat. And the IV has presumably everything in it that would at least keep you alive. Well, you take that idea and move it to the hydroponic world, it's really kind of the same thing. You're delivering the food to the plant without it having to go through the process of finding it and digesting it the way it would in nature. So you're bringing the food to the roots instead of the roots venturing out to find the food. So it's very much like that IV. The food is just brought right to you and put right into your veins. In this case, with hydroponics, the food is brought right to the plant and distributed right to the root zone where it can be uptaken by the plant. The consequence of that, or the result of that, is that the plant gets everything that it needs if the nutrient solution is properly prepared. And because the plant is getting everything that it needs, it's healthier, it's growing faster, it's growing stronger, its leaves are more efficient as little solar panels, its stalks are stronger to support its own weight and to support the weight of future fruit. It is overall bushier and fuller with more what are called internodal sites, where that's sites where branches come out and fruit can be produced. So you can have a tomato plant with 10 internodal sites, where you'll get maybe 30 tomatoes. You can have a tomato plant with 50 internodal lengths, or internodal sites, where you'll just get a bush full of tomatoes essentially. So there's a big difference in how these plants grow based on how efficient we are at delivering what they need directly to them. So, and this is easy to see when you start growing hydroponic anything, and you lift up the cover of your grow chamber and you take a look at those roots in there. Although it does seem like there are a lot of roots, but compared to plants outside, there really are not. But what's interesting is when it's grown hydroponically, you get a good look at just how sophisticated the root structure is on these plants, and how many hairs these little plants grow, these little roots grow, the root hairs. And they really do become efficient at pulling those nutrients out of a very small space when you're growing hydroponically. It's interesting to watch. So that's something you're going to want to look for as you go along, is take a look at the roots and check them out, because they're pretty interesting. Okay. Now let me see. Now I know I'm supposed to be having a chat control here, but I do not see the chat window. So if you all out there are trying to chat with me, I apologize. I don't see a chat window. I'm going to have to spend all of next week figuring that out. Okay, anyway, moving on. Let's go on to types of hydroponic systems. Okay, I apologize for the lack of chat feature, but still leave your comments and I'll go through them. And if they can help me to make better videos, I thank you for that. And yeah, so go ahead and comment away. Let's see. So yeah, going over a couple of the different kinds of systems that exist out there in the world. There are some that you're going to find more than others, particularly if you're shopping for your products on somewhere like, an online hydroponic supply store or Amazon or somewhere like that. A lot of the gardens, the self-contained systems that you're going to find, I have one. Well, I have a wall of them behind me, literally. I was trying to find one that I could show you around. Yeah, hold on one sec. All right. Okay, so and I'm just using this as an example. This happens to be the garden that I sell with Aero-Gro, but it could be any other garden that's similar, because they do function in a similar way. But to start with, most of the gardens that you're going to find are a water culture based system. The first diagram that you see there, that's called water culture. What's happening here is essentially there's a basin full of water. Yeah, you can see that here. Okay, yeah, there's a basin. Oh, good, showing up pretty well on camera. So there's a basin. This is where your nutrient solution goes. And inside here is a pump that aerates the nutrient solution. Basically just puts oxygen into the nutrient solution, keeps it moving, which keeps it fresh. It keeps it from stagnating. And that's a very common feature you'll find in any hydroponic system, is either an air stone or a water circulation pump. In this case, it's a water circulation pump. Literally, the water enters through the bottom of the pump and shoots out a little spout here and keeps moving in a kind of a circular direction around the tank there. So this is about just over a gallon, 1,000 milliliters, 1 liter of water. So It's a good size for about a dozen plants. As you can see behind me, it's the same garden again growing behind me, and it can be used for growing everything from leafy greens to small tomatoes and hot peppers. I have some beautiful hot peppers right behind me here. And these are very common, and they're very self-contained. They contain all the pieces that we're going to talk about in a little bit, but the nutrient tank, and then this is where your plants grow, and then you have an extendable. This is also very common, some sort of extendable hood, light hood, which allows you to raise the light up as the plants grow. Because one thing in hydroponics you're always concerned about is the distance of the light from the plants. You want the plants to get as much light as they possibly can. That being said, you don't want to give them too much light that they actually become dried out or burned. So we'll go over that too later. I'm getting ahead of myself a little bit here, but these are the basic components. If you look under here, there's the light hood here, and that contains white, red, and blue LEDs. We'll talk more about that later. But those are the basic components, and then a control panel on the front there that you can use to control it. So that's the water culture system, where the roots of the plants are literally dangling in that vessel of water, and the water is simply aerated, and then the plants take up what they need, and this is a continual cycle. And then as the caretaker of the garden, you simply prepare nutrient solution ahead of time, and then add the nutrient solution to the tank when the level gets low enough that it requires filling. And it's pretty simple. I mean, it's a very straightforward system. There's not a whole lot that can go wrong. There's nowhere for the water to leak out. The aeration makes sure that everything stays fresh. It's quite simple. There's only one pump. So it's a good system. It's a very reliable system, and I've used it quite a bit and designed quite a few systems around that principle. Then you have an ebb and flow. The ebb and flow is pretty neat. I built one many years ago, about 25 years ago in Florida, on a porch outside the house. And so what happens with this is that, again, you have a nutrient tank, but the nutrient tank is a separate entity. And it could be a standalone deal that's 5 or 10 feet away from your grow area, or it could be placed underneath your grow area, anywhere you want, really, and it can be fed with tubes. But what happens is the nutrient tank, again, has some aeration, and then it has a pump in it, a fluid pump. And there are different types of pumps, and that's something we'll also be talking about, and I believe that's in part 2 or possibly part 3 that we talk about that. But the pump will deliver the solution to a separate grow area. So let's say, imagine, if you will, a gutter from a house. Very often, hydroponic setups at home, people use gutters as their runners, their channels to hold the plants. And just picture that this gutter is maybe, 5 or 6 inches high, and you've got maybe 10 or 12 plants in there in little holes, and their roots are hanging down inside the gutter, and there's a cover. They're poking up through the top. So imagine, if you will, about every 15 to 20 minutes, nutrient solution is pumped into that channel, fills up the channel, feeds the roots of the plants continue to grow, and then a minute or 2 later, another pump turns on and pulls all that water out, or lets it drain out through gravity back into the nutrient tank. And that just keeps happening all day long. It fills up the reservoir, feeds the roots, and then drains back down. Fills up and drains down. That's the ebb and flow method for growing. It's a great method. The roots love it, actually, because what happens in ebb and flow that does not happen in a water culture is that in an ebb and flow, your roots are exposed to the air. And it's kind of difficult to explain, but through experimentation, I have found that when roots are exposed to air during the cycle, or even air is blown on them with a fan, even for a few minutes, there's something about that going from the drier state to the wetter state that the roots love, and it makes them grow, seem stronger. It seems healthier, and there are a lot of there seem to be some advantages to that. So The ebb and flow system is not as popular because it's more complex, because you have to get the water to the grow chamber, and then you have to get the water or nutrient solution back to the nutrient tank again. And that ebb and flow cycle is a little bit complicated. It requires timers and pumps, and people tend to get a little scared off by that. But there are advantages to it, in my opinion. So we will do videos about that in the future. But for now, I just wanted to cover it as one of the possible ways to go with hydroponics. So the next one, which is aeroponic on the bottom left here, is my personal favorite. And you'll get to know that after a while. So for the last couple of years, I've been experimenting with aeroponics and with different types of sprayers. Well, let me explain what it is. So again, we have a nutrient tank, as we always do with any of these methods. But with aeroponics, the difference is, instead of dipping the roots in the solution, or instead of filling up a chamber and letting the roots become immersed like an ebb and flow, with aeroponics, you're spraying the solution onto the roots. Now, this gets interesting because, in effect, you might say, yeah, okay, what's the difference? You're getting the roots wet, and then you're letting them dry off and getting them wet again. It's very much like ebb and flow. That's true. It's very much like ebb and flow in that way. The difference is possibly that the sprayers that are coming out now on the market that are being used for aeroponics in certain applications can put out such a finely atomized droplet, so small that it's thought that that makes it easier for the plant's roots to uptake the solution, because the particle size is so small to begin with. And if you look at the roots under a microscope, you'll see how they pull in through capillary action the nutrients. And if you can deliver those droplets small enough, that capillary action becomes more efficient, it's thought. So a lot of this is theory still. We're trying to figure out why it works as well as it does. I'm not convinced that there's anybody with absolute proof why these things are true, but it has been shown that aeroponics can grow significantly faster than any other method, and it's thought that it's that capillary action combined with the droplet size that makes that possible. I tend to think, this is my theory, that it's also that drying, wetting cycle that it goes through, much like the ebb and flow, that might be the reason, or one of the reasons, or contributing reason for that increase in growth, or that stimulation to growth. But it's not proven yet. But anyway, aeroponics is the method of delivering it through a spray. Again, it's a bit complicated because you have, in my case, with the systems I was building, there were pumps, there were valves. You had to open a valve to let the solution through at the exact same moment that the pump turned on. Otherwise, the water would come back down the tube and would, we'll talk about that later. But there are disadvantages to aeroponics just specifically because of its complexity. So it's great if you're building a system, or if you're buying a system that's already aeroponic, that's great. If you want to build one, we should talk, because there's a lot to it, and I would like to do some videos on that as well. But it is a more complex system, but I have a lot of faith in it that it's going to prove itself going forward, even more than it already has. So stick around to find out more about aeroponics. Okay, and then nutrient film technique is kind of an amalgamation, not an amalgamation, but kind of a combination of ebb and flow, where it's a little simpler because you're letting gravity bring the nutrient solution back to the nutrient tank instead of a pump, or instead of a valve, or instead of a combination of technologies. So you're literally, if you can see that from the diagram there, your plant trough or tray is just elevated just a tiny bit. It's dramatic in the illustration. It's not actually that tilted, but that's just for illustrative purposes. But gravity will feed it back down through a tube and back down through the nutrient tank, where again, it will cycle every so often, and that cycle will just continue. Now, the difference here is that between it and ebb and flow is that in ebb and flow, the reservoir, the trough, is actually filling with the nutrient solution. With NFT, or nutrient film technique, The solution that is being distributed to the grow trough or the grow chamber is simply touching the roots on its way down and out of the trough. It's running in a stream past the roots as they dangle in the stream of flowing nutrient solution. And then the nutrient solution simply makes its way back down to the tank through the tube on the other end of the trough. So there's no filling up of any kind. The advantage of that, I suppose, you could say, is that since there's no filling up, there's no potential for flooding or anything messy like that. It's a bit simpler because it's using gravity. It's using a bit less technology because it's using gravity. And yeah, you could say that it's a bit simpler. But in all these systems, as you can see, really, we are talking about the same thing. I mean, we're talking about plants that are having their roots exposed to nutrient solution in one of a variety of interesting and creative ways. And why would you need all these different ways? I guess would be a good thing to talk about. I hadn't planned on talking about that, but we probably should. So as you know, with any of these methods, water savings is incredible. I mean, you use about 90% less water than you do with soil-based technologies. And with aeroponics, for example, you can get away with less of everything. It's a lighter weight system. That's why it's being chosen for space. On our journeys to Mars, aeroponics is one of the technologies that's being investigated for use growing food for long journeys with a very small amount of water, all of which is recycled on board. So it's very, very efficient. All these systems are efficient, but aeroponics is even a small amount more efficient, a tiny bit more efficient than some of the others. So, or can be made so. So that's one of the advantages. The other thing is when you start to grow vertically. In other words, and we'll talk about that later too, but you can grow on a pallet, let's say, or on a flat, on a single plane, or you can grow upwards, put a pallet on top of a pallet on top of a pallet and grow upwards, and then have lights underneath each level. If you're growing vertically, you need everything to be very lightweight. And that means you're not going to want to fill up a lot of tubes with a lot of water because water is extremely heavy. So with a vertical growing technique, very often you'll see nutrient film technique or aeroponic being used for installations like that. And that keeps down the weight, and it also keeps down the mess and the potential for flooding and lots of other problems. So yeah, there are advantages to some of these. It's cheaper and easier, however, to build something like a water culture system in your own house, because now you're just talking about a bucket with an air stone and a light and a couple other things that we can talk about. But it's a very, very simple system, the water culture system. And that's its advantage. Its disadvantage, you're dealing with a larger amount of water. That's really the disadvantage. And there are some smaller disadvantages, but that's the main one. So I would say, depending on how sophisticated you want to get with it and what you're trying to do, you could pick any of these and be very successful with it, because beyond the design of these basic systems, everything is more or less the same. You're preparing the nutrient solution in the same way for any of these systems. You're placing the systems in a similar type of location. You're providing them with light the way that you would in any other installation. And in many ways, and they're all using either an air stone or water circulation technology, they're all using the same things. So really what it comes down to is, what do you feel comfortable working with? What's most comfortable for you? Would you rather be the mad scientist, which is my favorite, and get your hands dirty and really design something cool and interesting? Or would you rather keep it simple, as many of my customers would? They would rather, because they work all day, they don't want to be complicated about it. They want to come home and pick their veggies and eat their dinner and go on with life. And that's totally fine and understandable. And if that's the case, and by the way, those same people maybe do a little experimenting on the weekends and put together a system from a video on YouTube or something like that. But other than that, they want to keep it simple, and that's totally fine. So we will go through how to build a system that's simple like that, and to try to keep it from getting too crazy. All right, so types of lighting. This is also kind of a important and popular topic for questions. I get a lot of questions about lighting, and not always about grow lights, but people ask me about lighting for other situations too. Lighting is very popular. So back in the old days of indoor growing, you didn't even have these fluorescent lights like you see on the screen here. These are, believe it or not, a relatively recent contribution to the world of lighting, but they're not as old as some of the others, like we'll talk about in a second, halide and sodium vapor. But the compact fluorescents are very inexpensive to buy. They're, well, I guess maybe $8 or $10 for a bulb that looks like this one. Grow light maybe a little bit more for a decent quality one, but they're very inexpensive. They run off of your normal house current. You can plug them into a normal Edison style socket, which is kind of convenient, which means you can plug these into a lamp or into well, anything you want that has an Edison style socket like that. And they're easy to work with. They run very cool. As you know, any fluorescent light runs very cool to the touch. It's not going to get hot. And that's really great, especially in a household environment, because you're talking about growing in closets and growing in small tents and small spaces, maybe a spare bathroom. And what you don't really want is a lot of heat. So compact fluorescents are really great for that. They'll keep the heat down. They put out a decent amount of light for what they are. I mean, it's not great, but they're pretty good. They're efficient enough, and not as efficient as LED, but they're okay. It's an older technology, which is why you can't really expect it to compete with the newer technologies, and certainly as far as efficiency, and certainly not as far as the actual wavelengths of light that it can produce. And we'll talk about that a little more in a sec. But they're great for maintaining lumen output over time. What that means is fluorescent lights will put out the same color of light and the same amount of light from the moment you turn it on the first day you buy it until the moment before it dies on the last day on Earth. It will produce the same exact light. It will never degrade. It will never change. It will never lower the light amount. It'll stay the same. That consistency of delivery, light delivery, and that's very good with fluorescents. I suppose you could call that a positive thing. And they can also be purchased in a dimmable variety, which is a more recent contribution. And that's important to when you're, especially if you're using a lot of them and you're leaving them fairly close to your plants, you need to be able to turn the light up and down depending on where your plants are in their growth cycle. So that if you're growing seedlings, for example, that you're not going to burn up your seedlings. By the way, fluorescent is pretty good at one thing in the world of indoor growing, and that is for seedlings and microgreens. And for those types of growing, it can be quite good, especially for seedlings, when you're just growing seedlings. And the reason for that is because seedlings don't require a particular type of light. They just need light. And it doesn't have to be particularly high quality when they're seedlings, but they're good because they won't burn your seedlings. And that's something that happens pretty often with other types of light, is that other types of light are placed too close to the seedlings and then they get burned. So fluorescent is great. If you wanted to, in fact, if you wanted to split the task and use fluorescent for the seedling stage and then use other types of light for everything else, that would not be a bad way to go. And it would be a good use for fluorescents. So the not so good about them, as we were talking about, the wavelength of light that they produce is iffy at best. Plants need, we should talk for a second about that. Plants need 3 different types of light, generally speaking. They need white light, and they need blue and red. And the white light is for growth, and that's really what they're chewing on most of the time. Your plants are eating mostly white light. However, and white light is, by the way, white light is what you would have during the midday of a nice summer day around noon, 1, 2 o'clock. That's the sort of color of light that we're talking about when we're talking about the white light. Towards the spring or fall or the early morning or the later in the day, you have a much redder orangey type of effect going on. And those are the colors that are necessary for your flowering and your blooming and your fruiting and all. You need to have other wavelengths to drive those cycles in the plant efficiently. And fluorescent light is not very good at producing those blues and reds. It's pretty good at producing the whites. So that's why it's good for the seedlings, but not so great for your flowering stage and your fruiting and budding stage and all of that. So that's why we stay away from those for any serious grows. They are difficult to control because, as you know, with fluorescence, they just shoot light everywhere. You can't even tell where it's coming from. It just glows. And that is nice, I suppose, for lighting up the inside of a store, lighting up the inside of a kitchen, maybe, something like that. But with plants, you want to be able to direct your light to where the light needs to go. Where the light needs to go is onto the leaves. It needs to hit the leaves directly. And if you have a fluorescent light shooting light everywhere, only a small amount of it is ever actually reaching your leaves. So in order to get that light to your leaves, you have to move it closer to the leaves. And then you're talking about using more lamps, because now you're concentrating it down on your plant. It's a kind of a cumbersome way to work when you're working with a light that spreads out everywhere like that. So that's one of the disadvantages of compact fluorescence. Also, it does contain mercury, which is there's just no safe way to dispose of mercury. It's just very, very toxic. And you toss it into the trash, and the trash makes it into the landfills, and who knows how long it's going to be there for, but it's going to be there a long time, and there's no way to make it safe. So it's one of those things where if it's possible to avoid fluorescent, avoid it. And if you can't avoid it, if you'd rather use it for seedlings or something like that, go ahead, but keep it, I would say, just use them in a very kind of minimal way, maybe just for that task. And don't buy 100 fluorescent bulbs and try to light up your whole grow room with fluorescence. I think that would be pretty inefficient. So that's the last word on CFLs. Okay, so the other thing we can talk about that is actually kind of an older technology is sodium halide and high pressure sodium. Now these puppies, wow, these were the first grow lights to be used a long time ago. And I've had these before. I haven't had any of these for years and years. But what I can tell you is they run very, very... I'm not going to talk about the bad stuff first. I'll talk about the good stuff. Okay, the good thing is this, about the sodium halide and high pressure sodium. Sodium halide produces the closest thing to natural white sunlight, that midday to 1 or 2 p.m. sunlight that you can possibly create with an artificial bulb. It's just amazingly good. It's great. And the high pressure sodium produces the other wavelengths that we were talking about really well, just like the sun would, really well. The downside is that you have to combine them together in order to get your full spectrum for your entire growth cycle. That's kind of a disadvantage, but they do produce light that is very good quality and very good spectrum quality. And that's good. The not so good is they're extremely expensive to operate. They run very hot. Anything that runs hot, by the way, is inefficient. That's what that means. If any appliance in your house that gets hot to the touch, it just means that it's not very efficient. And these bulbs, while they are massively good at producing great light, are also massively inefficient. That's why they get so hot. And that is a problem in a small space, especially in a home. And these things, from what I remember, and again, I haven't touched them in a long time because frankly, they scare me, but these things get so hot, they are dangerous. And it's fine, I suppose, for somebody who has a lot of space and they have a proper grow room set up and they know what they're doing. They could use these, and they don't mind paying massive electric bills. They could use these and it would be fine. But other than that, I don't think I would ever recommend these today for any sort of a grow installation. They're out of date, they're too hot, they're dangerous, and they're going to burn your house down. Move on. Okay, here we go. LED panels. Let's talk about LEDs. Now, moving from the scariest lights in the world to probably the best advance, the most significant advance in lighting that's happened to the world of growing has been LED panels. LED panels are available in absolutely any configuration you can imagine. If you go on, just go do it. Go on Amazon and look up Aero-Gro panels, and you will spend hours looking through all of the options. Now, that's all well and good, and there are some other good things we're going to talk about with LED panels, but that can also be a bad thing. There's to having so many options available that you don't know where to turn. We'll cover that. So lots of options for any budget. That's a good thing. So if you only have $100 to spend, you can still buy yourself, believe it or not, you can still buy yourself a half-decent LED panel for about $100. You can do it. You probably won't be your last. You'll probably get, dissatisfied with it after a while, or you'll outgrow it, or you'll want more or better or something. But you can get into the game for less than $100 and get yourself a full panel, color-balanced panel, and get in the game. And we'll take a look at that. So what's nice about these panels, a lot of nice things, but they're color balanced, because here's the thing about LEDs. LEDs are very good at producing a specific wavelength of light. So if you have an LED, single LED bulb, it is producing a wavelength of light that you could measure on an oscilloscope that would be specific. It's one specific number. Like, I don't even know what it would be, but let's say it was your scale was 1 through 100. A particular LED bulb would produce frequency 17 every single time that you turn it on, right? And then every other bulb that's like it, manufactured in the same batch, would produce 17, frequency 17, right? So they're very consistent about that. Now, why that's powerful is because you can combine those LEDs together to produce a cross-section of color frequency. So in order to get those white and blue and red frequencies that we're looking for the different growth cycles, we simply need to take a whole bunch of LEDs and combine them all together on a panel in any combination of those colors that we want. More or less of the red, more or less of the white or the blue. And we can really fine-tune that, and each manufacturer does that. They fine-tune their LED panels to deliver whatever wavelengths they believe are the proper wavelengths for the plants that their target audience or target market is growing. So that's what they try to do. Now, that's very efficient. It can be done very well. Certain manufacturers do it very well. They're inexpensive to operate because LEDs are extremely efficient. This is why they run so cool. I don't know if you've ever played around with LEDs, but if you ever go up to anything that has an LED, which is anything electronic in your life, and you touch the LED when it's been on for a while, you may feel it get a tiny bit warm. It'll never get hot, and it'll never really even be all that warm. You may be able to detect it, but that's how cool they run. And they run that cool because they're extremely efficient. Now, when you put 1,000 of them on a panel, okay, that's going to be a little bit of electricity, but nowhere near what a metal halide or a sodium halide would be. Your LED panels will always be far, far more efficient than those are, especially when you're considering for the same amount of light that they deliver. So when you put them on side by side, you take a sodium halide and you take an LED panel and you measure them, and you have each one is putting out the same amount of light. The LED panel will be far more efficient because the sodium halide is putting out a lot of its energy as heat. If you remember, that's because it's inefficient. The LED is using that energy to produce light because it's efficient. Less heat, more light. Better deal. So that's what you're looking for, are LED panels that are color balanced. And another nice thing about these panels, by the way, is they are easily dimmable. I think all the panels I've seen for the past year have been dimmable. There are still panels available, very inexpensive ones that are not dimmable, but for the most part, the half-decent panels that are available on the market now are all dimmable, and they're very well color balanced. And they're also daisy chainable. What this means is if you decided that you wanted to expand your grow later on and you wanted to add another LED panel to it, you could simply plug the first panel into the second panel instead of running separate cables for everything. And then they would be powerable and addressable from a single point. So they're expandable. It's like daisy chaining anything. When you add one in computers, I know back in the day, things like printers were daisy chainable, disk drives were daisy chainable. You could add a device on back of another device on back of another device, and then that final one was connected to your computer. That's the idea of daisy chaining. Well, the same thing is true with lights now. And lights are very often controlled by an app. And that app now can control your entire daisy chain of lights that are plugged into each other. So you could have 16 panels, 20 panels, 500 panels, and they would all be controllable by that single app on your phone. At one time, you'd be able to control the whole array of lights. That's the power of daisy chaining. And that's also the power of certain hydroponic systems as far as how they're designed. They should be expandable, following that same sort of daisy chain concept. We'll talk about that more later too. But the not so good about LED panels that I have found personally and that I've heard from others as well is that there is a great deal of inconsistency among manufacturers. So what it really comes down to is the LEDs themselves. And I used to work at a company that dealt with these LED traffic signs you see on the side of the road that tell you to merge left or traffic ahead or whatever, and they change, their messages change. And I remember the owner of the company telling me that the LEDs really, they vary so much that in order to get an entire panel of the same color LED, they have to be hand selected. So literally, I don't know if you can even imagine this, but these companies are producing tens of thousands, millions of LEDs per week, month, whatever. And all these, let's say they're red, all these red LEDs are slightly different from each other. They're all red, but they're very slightly different from each other, just enough that if you were to put 1,000 of them in a panel, you would see the inconsistency between the different LEDs. If you were just looking at one, you would never see the inconsistency. But if you're looking at them next to each other, 1,000 of them, all the same color, you'll see when they get turned on that some of them are slightly pinkish, some are deeper red, some are brighter, some are dimmer. That's just the nature of LED manufacturing. So what happens is this. If quality is really important to you, as it was to my former employer, and as it is to some of the better manufacturers of LED grow lights, then they will go to the trouble, first of all, of buying LEDs from a major manufacturer like Samsung or LG, companies like that, major brands. When they make LEDs, those LEDs are, first of all, the quality level's higher. And then when they are passed on to the manufacturers of these panels, these panel manufacturers will hand select them and match them so that you're getting the proper colors for your grow light. And the ones that don't fit the bill will get rejected. Now, that doesn't happen with every manufacturer. Obviously, it costs money to go through these LEDs and to hand select them. So when you're looking at LED panels, just remember that one of the things you want to look for is that the LEDs themselves are from a major manufacturer. LG or Samsung are the two that I do recommend looking for. There are others, but those are the two to look for. And if you have, this is the thing, if you start out with LG or Samsung LEDs, you're already out of the gate, you're much better off. Because each one of those LEDs will be made to a higher tolerance, to a higher quality level, and they'll be better matched to the color profile that's expected right out of the manufacturer. So look for that when you're looking for your LED panels. Also, you want to look for, well, we talked about the daisy chaining and the dimmability. You want to make sure they're dimmable. That's really important. You want to make sure that the casing is aluminum. You want really good venting on these cases. If you've got cases, I've seen actually LED panel cases made out of plastic that were intended for grow situations. I don't recommend that. The aluminum, I think it tends to dissipate the heat better. And the way that these aluminum cases are built, they tend to be sturdier, usually, not always, depends on the manufacturer. But I would always recommend the aluminum just because of that heat dissipation. I think that's really important. With the plastic, you don't get that. So take a look at that. The other thing, what else can I tell you about these panels? These panels they're hung from the ceiling, from the roof rather, of the grow tent or the grow space, and they can be hung with a wide variety of different little clips and cables and all sorts of different things. And that's another thing we can talk about later, but they're really adaptable is the bottom line. So you can hang these things vertically, or you can hang them on their side, you can hang them upside down, literally, you could hang them upside down if you wanted to. You hang them in any orientation that you want, and that's one of the great advantages of this for indoor growing, is because sometimes you're working with spaces that are unusual inside of a house, and you need to kind of cram a light into a space where it might be tight to fit it if it was done any other way. And with a small panel, you can just hang it on the wall in any direction that you want and then wire it up, which is pretty nice. You can also use these panels, smaller ones, to fill in shady spots inside of a grow room or a grow tent. They're really great for that. So you can light up underneath the canopy if you wanted to. So they're really variable as far as that goes, and I recommend them for so many applications. So LED is definitely the way to go. Now, with all that being said about lights, one thing I wanted to mention is the way we measure light is what's called PAR, or the photosynthetically active radiation. And what this refers to is, well, I should say this. There are two different measurements, two different ways typically that we measure light in the world of indoor growing. That's lux, L-U-X, and PAR, P-A-R. Lux is simply the amount of light that is coming into a space from a light source. The amount of light falling on the surface of a thing. That's what that is. So when we talk about PAR, however, we're talking about we're not talking about the quantity of light. We're talking about the quality of light. We're talking about light that has the correct photosynthetic color profile to be maximally used by plants. So a PAR meter is measuring the light, put it this way simply, a PAR meter is measuring the light you actually care about, or put another way, a PAR meter is measuring the light your plants actually care about. So a lux meter is great if you're trying to design a romantic environment for a new restaurant. That's where you'll use a lux meter. Keep the lights low and make it nice and romantic. Okay. But if you're measuring light for plants, you have to be measuring using PAR. It's the only correct way to measure the light. There are lots of people out there on the internet that will tell you that there are ways to finagle your way around that. Buy a really cheap meter to measure PAR. Can't do it. But the reason I mention this is because when you're shopping, not that you have to buy an expensive PAR meter, you don't, but when you're shopping for an LED panel, for example, you're going to have any respectable manufacturer should be showing you some diagrams showing the PAR output of your lamp. And this is just a demonstration or example, rather, that I'm showing on screen here for just a random image of a panel. It's not a particular panel at all. It's just used for demonstration. But this particular panel, for the purpose of demonstration, puts out from 12 inches away from its surface 1613 PAR, or micromoles. That's the measurement of the light. And as you move down, the point of this diagram is to show you that as you get farther and farther away from the light, you receive, or the plants receive, less and less light, quality light, less PAR. And it's below PAR. The light is below PAR. So That's really important because your lights, in order to be maximally efficient, they need to be at the correct distance from the plants, and you need to have the right power output. Now, the lights, when they're being sold, they will give you some numbers telling you how that lamp performs, and that's what you can use to compare one light panel to another. If you have two panels and they both have, for point of example, LG LEDs are both dimmable. They're both all of the good things we talked about. They both have color balanced LEDs, all this and that. And then it comes down to the power output, and they're both the same price. Well, obviously you're going to want to go with the one with the higher power output, because it simply means that you have the potential to put out more quality photosynthetically active radiation with that light. And that's what you need. That's what your plants need. So at the end of the day, it's really about that power output. That's really what it comes down to. And that's the critical actual business number that you need from your shopping for LED panels, is that power value. And look for that diagram when you're shopping. Okay, so let's see here. The next thing I just want to get, and this is kind of a funny one. So I've been asked before a number of times about a number of different things. Is this or that simple? Or how simple is hydroponics? That's how it's usually phrased. And all I can say is this: it's kind of a strange question to answer. My father used to say, when I would ask a strange question like that, he would say, "Well, Andrew, how long is a ribbon?" I don't know. What do you mean? It's like you can't answer that, right? So it's like, how simple is hydroponics? Well, I will say it this way. If you have ever kept an aquarium, right, and by that I mean successfully, if you've ever had fish in an aquarium that survived for any length of time, and you know what that requires, you have to watch your pH and change the water occasionally and keep an eye out for diseases and things like that. If you've done that successfully on any level, that's pretty comparable to what you do in hydroponics. I mean, it is, well, quite literally in some ways. I mean, you are really looking at pH with an aquarium, just the way you are with hydroponics. You're feeding your fish, you're feeding your plants, you're taking care of the water in both situations. Yeah, there are a lot of correlations between the two, but really I would say if you've done that, you're ready to get into hydroponics, no problem. And even if you haven't done that, it's not that difficult. So with that in mind, what you're looking at on screen here is no joke. When you go to start roots on a new plant, take a trimming, put it in a glass of water to get roots so that you can transplant it, you're practicing hydroponics. You are literally practicing hydroponics. You are feeding, well, you're not putting food in the water, but if there was a little bit of food in that water, that would be hydroponics. You're feeding the plant through the liquid nutrient solution with no soil involved, right? In a container that can support it. That's hydroponics in its simplest form. And that's what you see on screen here. Now, that's all well and good, but it can also get pretty complicated, as you see here. Now, what's interesting, though, is that fundamentally what you see in this photograph here of what is most likely an indoor grow operation in the Far East, it's probably in Asia somewhere. This is very complex. There's computers and timers and pumps and all kinds of fanciness going on here. But really, at the end of the day, what we're looking at is something that is based on the exact same principles as this. It's the same thing. The only difference, well, the only difference, yeah. The only real difference is the level of automation that's happening here. Because these plants are in this complicated, complex indoor installation. They are being monitored 24/7. They're being fed a very specific diet at very specific times. Everything is regulated in a way that they can make predictions about the growth of these plants down to the minute. It's incredible. And even the when it comes time to harvest, they have robotics now that are harvesting plants in vertical installations like this. It gets very complex, but at its base, at its root, at its heart, it is as simple as that jar of water with a plant in it growing roots, because that's what's happening in this place. It's just done in a way that's highly controllable. But it's the same thing. All right. So let's take a look at some of the tools and supplies, let's see here, that you are going to need in the world of hydroponics. First thing I'm going to mention, and this is a must-have. There was a time where I might have said this is not a must-have. I might have said, oh, yeah, 5-in-1 meter, that'd be nice to have. It'd make your life a lot easier. In my opinion, if you are getting into hydroponics, you must have some sort of a water testing meter. Now, this one that I'm showing on screen, again, this is one that we sell. You don't have to buy ours. It just has to be a meter that can measure pH, EC, and TDS. That's pH, or potential of hydrogen, EC, electrical conductivity, and TDS, total dissolved solids, which is measured in parts per million. The reason you want this is because the way that we measure the density or the intensity or the strength of the nutrient solution in hydroponics is by using a 5-in-1 meter. We measure, in fact, the electrical conductivity of the solution, because it's a very simple concept. When you start out with distilled water, clean, fresh, distilled water in a jar, it has no electrical conductivity, nothing. It will read close to or 0 if you put the meter in it and take a reading in either EC mode or TDS mode, 0. You then take some nutrient salts, an AB solution, a nutrient preparation, and you add it to the water. All of a sudden, the water is electrically conductive because those salts are electrically conductive. And now the numbers on your meter go shooting up. What is that telling you? That is telling you specifically how much of those nutrient salts are in the water. And by knowing that, you can control on the fly at any time the strength or the strength of your nutrient solution by measuring the electrical conductivity. Now, the pH is another thing it can measure, and the pH is something you also can measure on the fly, should measure on the fly, and can control on the fly when you're growing. The only way to do this effectively really is with a meter. You need to be able to go over to your nutrient solution, dip it into the water, get your reading, and make the change. And because your plants won't wait. You're the one that's controlling that. It's very simple to do, but the most accurate and easiest way to do it is with a meter. Like I said, it doesn't have to be ours, but it does have to be one that will measure EC, TDS, and pH. And let me see, is there anything else I want to say? But no, that was it for that. Yep. So now the other thing I want to talk about, and this one's actually, believe it or not, is really important, measurement. Everything in the world of science and everything in the world of hydroponics, if done at all close to professionally, is done in metrics, okay? So you're measuring in milliliters and liters. Milliliters for the most part in a home installation because you're measuring small amounts. So to measure milliliters, if you're going into your cabinets in the kitchen to find something to measure milliliters, good luck. It is really hard to find anything in a typical grocery store in a kitchen section that resembles anything scientific or anything with metrics on it. So it's possible. You might. Maybe higher end products have that, but I haven't found any. So what I recommend is this. Just go to Amazon and get yourself a 50 milliliter graduated cylinder. Plastic. Get a 50 milliliter plastic graduated cylinder and a 100 milliliter graduated cylinder and a 1,000 milliliter plastic pitcher. If you get those three things, and I believe they're all made out of polypropylene, if you get those three things, you will hardly need any other measurement tool in your future for hydroponics. In my opinion, in my experience, these are the three things that I use literally every day. I've been using for a long time now, and I have other tools, but I don't use them. These are the ones that I use. So these are the ones that I recommend. They're not expensive. 50 milliliter, I don't know, it's $6 or $7. 100 milliliters, probably $10. 1,000 milliliter plastic pitchers, probably, I think it's $18 or $20, something like that. So with a one-time investment of those, are made out of plastic. They're going to last forever. With a one-time investment in those, you will be able to accurately measure your A/B nutrient salt concentrate and also be able to measure a gallon at a time your nutrient solution in this that 1,000 milliliter plastic pitcher is just about a gallon. So with those three tools, you'll be good to go. Those are the three I recommend. And not glass. Just don't get glass. It's a pain in the butt. They're always breaking and they're kind of expensive. So just get the plastic ones. You'll be good to go. The other thing you're going to want here is pH up and pH down. Now, the way that works and where you use that is after you have prepared a gallon, let's say, of nutrient solution using your new 1,000 milliliter pitcher and your other tools, you will add your nutrient solution to that, and that will most likely drive down the pH. It'll go low on you. And we're going to talk more about pH later, but it does have to be from 5.5 to 6.5 for hydroponics. That's your range, 5.5 to 6.5 for just about everything. And you'll find that after you add your nutrients to your water, that the solution is now, the pH drops down to 3.5 or 4 sometimes, pretty low. So to bring that back up, you need to add some pH up in this case. Now, there are other things that you can do to the nutrient solution that will cause it to go up. It'll spike upwards, and then you need to bring it back down. But for the most part, you're going to be wanting to bring it up. And for that, we use this pH up and pH down. pH up and pH down is simply a bottle each of an acid and a base. And they're just used to counteract whatever your solution is doing to drive it in the other direction. It's very simple. And any brand of this stuff is fine. You'll see if you shop for it on Amazon that they all look basically the same. There's a blue bottle and an orange bottle. That's an industry standard, scientific standard it's a safety standard, so that you can identify what they are. And so they come in these two colors here, and any brand is fine as long as they are meant for hydroponics. Don't get anything that's meant for your pool, maintaining pH in a pool or anything like that. Make sure they're for hydroponics, but that's the only rule really. And here's the other thing. Always when you are balancing your pH, always do everything you can at room temperature. The reason I say that is that pH is affected, or the measurement of pH is affected by temperature. And everything is typically okay as long as it's at more or less room temperature, right around, I would say 65 to 72 degrees, you're fine. As long as everything's at the same temperature. You don't want to be mixing a couple of cold bottles of solution with really warm water and then measuring it with a cold meter, something like that. You don't want that. Just make sure it's all been sitting around inside for a while when you do your measuring or mixing, and you'll be fine. Okay. So hydrogen, let's put this up here. Hydrogen peroxide is going to be your best friend. Well, hydrogen peroxide probably has a lot of other friends in your medicine cabinet that you don't know about, and they have big parties at night. But for the purpose of growing and hydroponics and keeping you and your plants safe and happy and healthy, hydrogen peroxide is your new best friend. Because hydrogen peroxide is completely safe for plants. Not only is it safe for plants, I'm not going to talk too much about this yet, but I actually add it to the nutrient solution as a little booster. And I'll talk about the ratio of that later and what that's good for. But hydrogen peroxide is so safe, I literally add it to the nutrient solution. Don't do that yet until I tell you how. But it's very safe. So when it comes time to clean anything in your hydroponic installation, from tubing to the little baskets that go in your garden, to your tools, to the inside of your nutrient tank, to just wiping down the outside of it, anything at all of it can be done with a mixture of water and hydrogen peroxide. And in some cases, just straight hydrogen peroxide on a rag. I'll show you how to do that too. But hydrogen peroxide's great. The cheap stuff you get at the drugstore, dollar store, grocery store, box store, wherever, looks just like this. It's 3% USP hydrogen peroxide. Just look for that on the label. Do make sure you don't get pure hydrogen peroxide. That's a little trickier to work with. Just get the cheap bottled stuff that you see in the drugstore next to the Band-Aids and such things. And that'll be fine. And get a couple bottles of them because it's cheap and it's good to use, and you'll find other uses for it as well. So pick some of that up. All right, what else do we have here? Okay, how much can you grow? Well, you can grow a lot with hydroponics. You really can. Hydroponics, however, is done a little differently here in the United States, for the most part, than it is done in the Far East. What you're looking at here in this photograph is a photograph from the United States, somewhere out west. It's in a formal grow installation. This is a commercial farmer. And these are typical things you'll find in the grocery store now that are available. Your lettuces and leafy greens are very simple and fast to grow. That's why you see them in commercial installations a lot. They're very quick turnaround, high profit. But also, and I talked about this, in the Far East, you have vertical installations like this. And this is where you really, really start to maximize space. And actually, I don't think this is my official announcement of this. Well, maybe it is. Aero-Gro, my company, we will be putting out a vertical growing product in 2023. There, I said it. Now I have to do it. Now, we will be putting out a vertical growing system, not like this that you see in the picture, but it's a tower is what it is, a vertical tower system where you can grow up to, depends which one we get, but up to 30 plants vertically. And it has its own light source that surrounds it, and it's all self-contained. It's super cool, and you can grow much higher volume of vegetables because you're growing vertical, you're growing up. So that is an upcoming product for us, and this, hopefully, is an upcoming product for the United States, that this will continue to grow as far as an industry. We do have some indoor vertical companies here in the United States right now, a few, but they're not owned by us. They're owned by other countries, unfortunately. So I'd like to see that become a little more popular here, and I'm helping to drive that effort. But this is what it looks like, and it's fantastic. And boy, there's no greater place to go in and breathe deeply than into one of these greenhouses. That's for sure. Okay, so where to set these things up? Well, you can set up a small compact garden right in your kitchen, anywhere. You can set it up in a bedroom, in a classroom, in a bathroom. You set it up, I wouldn't set it up in the bathroom, but you can set these up literally anywhere. They're very small and compact. They're about 18 inches high, about a foot wide, about 6 or 8 inches deep. And yeah, fully self-contained. And you do want, now, one thing I will mention though, is that the light cycle for these, about 12 hours on, 12 hours off. So whenever you turn these indoor gardens on, you want to make sure that your light cycle is conducive to your living schedule. So for example, obviously you wouldn't want your garden turning its light on in the middle of the night if it's in your bedroom, right? But if it's in the kitchen, that's okay. In the middle of the night, nobody's in the kitchen. You can totally let it turn on and do its thing overnight. That's fine. But that's one thing to keep an eye on. But these gardens are fantastic. I mean, they literally, every principle of indoor growing can be demonstrated in one of these compact gardens, which is the reason that I deal with them. It's the reason I love them. And they're great. And even for starting seedlings that you then want to put outside in the garden in the spring, you can use them for that as well, to start your garden in the spring. It's fantastic use for these gardens. So many uses, but they are pure hydroponic technology, and it's a great way to get going. Now, another way to grow is with a tent. And this is where you're getting more serious, and you have a dedicated, allocated space in your home for a grow tent. And these grow tents, let me tell you, they come in every configuration and size you can imagine. Now, what are the advantages? The advantages are many, because one of the things you have to be aware of when you are growing indoors is humidity. Plants put out a lot of moisture. Yes, they take in the moisture and they use some of it to maintain themselves, but what they also do that most people are not aware of is they transpire through their leaves. Those little solar panels are putting out water vapor all day long when they're in the sun, and at night. but they will transpire and lose a large amount of water right into the air. And if that air is the air inside of a small room inside of your house with no ventilation, you're going to quickly have a problem. So ventilation is very important with growing, especially when you're growing in larger operations, because the more leaf matter that you have, the more humidity you have going into the air. So it is something to keep in check. Now, a grow tent will contain that humidity. You can literally close the doors on this tent and then hook up a fan. As you can see in the photo here, you can hook up a fan with what looks like a dryer vent tube to it. And then you could put that out a window or out a door or anywhere. You could send it outside of the house is the point and get it out of the space. And that's a super efficient way to go. But a tent allows you to do that so that the humidity isn't actually entering your home. It stays inside the tent and then it goes directly outside. Also, that could be used to mask any odors from any particular plants that you might be growing. You can put a carbon filter inline in that hose, and that will take any odors out of the air before it is evacuated. But tents are great also for maintaining temperature. So again, your lights are running pretty cool, but they, over time, inside of a closed tent space, are going to create heat, and that tent space can go up to 100 degrees with certain installations, and your fan and ventilation will help to keep that cool. And that's also important for the plants to have air circulation. They need to have access to that carbon dioxide. That's what they feed on. So you need to have good air circulation wherever your installation is set up. But tents are great for that. Tents are great for really taking maximum control of your grow space. The other good advantage of a tent is that it's very clean. You can clean the inside and then know that you have basically a clean room environment. And if you have cats or dogs or pets of any kind, a grow tent is a great way to kind of control the dust and dander and particulates that pets can produce that could cause you a problem in a grow environment. So that's something, and also the dirt that's associated with animals that you do want to keep away from your grow space if possible. So that's another advantage of a tent. Also, a tent allows you to hang your lights, hang your fan, hang anything and everything that you have that's associated with growing right inside that space. And it's very convenient. They're also very lightweight. They're easy to set up. It's just like setting up a tent outside that you might sleep in. It's very similar and very lightweight. And when you want to put them away or pack them away, they pack up very small, very compactly. And they're not very expensive. You can get a decent, let's say 2 foot deep by 4 foot wide by 5 foot tall tent for under $100, and you'll have that thing forever. They're pretty well made. They have big zippers on them, and all sorts of places where you can attach hoses and vents and fans and all sorts of stuff built into them. And every variety you can imagine is available on some place like Amazon or any of the hydroponic supply houses. So check them out. Okay. And let's see here, another possibility, if you get really advanced, you can just build yourself a green wall and impress everybody you know with your amazing hydroponic skills and recreate the gardens of Babylon inside your office. Check that out. That's pretty cool. But yeah, no, really, hydroponics can be used for absolutely amazing displays of plants and greenery. So before we wrap this up, I just want to take a look through here, see if there's anything I missed. I don't think so. Yeah, okay. One last thing I did want to cover that I get asked about more often than almost actually anything else. Growing herbs and medicinals. Okay. So people hear that I work with hydroponics. I'm usually pretty quick to point out that I focus on vegetables and food products, but they ask me, can you grow other things other than food using this technology? And of course, the answer is yes. All of the techniques, all of the supplies and tools and everything that we are going to be talking about can be used to grow a huge variety of plants inside your home. From fruits and vegetables to, yes, herbs, both for culinary use and also for medicinal use. After all, those medicines are nothing more than plants with specific needs like any other plant. They can be grown hydroponically like other plants. I would liken some of the medicinal plants to growing peppers or growing tomatoes, very similar. They're fruit-bearing plants. So yes, now what I will say is that it's not legal to do that everywhere, only in some states. And as of today, states that allow you to grow medicinal plants indoors or for recreational purpose are listed on screen here. This list is updated continually. There is a lot of activity in this realm right now, and I do expect that as a company that we're working a lot with a lot of growers who are growing medicinals at home, and that's no problem with that at all. That makes me happy. I'm glad that these plants can be useful, and I'm glad that we can help to provide really efficient ways of growing quickly and inexpensively to whoever needs to grow whatever they need to grow to make their own life better. I have no problem with that. So this is the state of things right now. You should really, though, keep, if this is what you want to do and get into this line of work, it's great, but do keep an eye on the legality of it. There are also local restrictions depending on where you live as far as what you can grow, how you can grow, where you can grow. So do keep an eye on that. So I just wanted to give you kind of a heads up on that. So there's no judgment about it. And yes, if you call me and ask me questions about growing medicinal plants and so forth, I will answer your questions like I would anybody else. Don't worry about it. I'm not going to judge. So yeah, absolutely. You can grow these plants using this technique. So next week, what we're going to be talking about in episode 2 of the 3-part series is what do plants really need? What do they really need to do well versus what companies are likely going to try to sell you, telling you that they need, which may or may not be true. We'll talk about that. What's the most basic system I can build on a budget on my own, with very little experience in my home, with a full-time job and so forth, which is probably your situation? We'll talk about that. Understanding pH, why it's important and how to control it. Because if there's one thing you hear about every time you talk about hydroponics, it's pH. So we'll get to the bottom of it. Nutrient solution, how to buy it, how to make it. In other words, how to buy it, what to choose if you're going to buy it already made, and how do you prepare it once you've bought the concentrate. Lighting, LED lighting, timers, setup, and more. You can see we're starting to get into next week into the actual technology for those who may want to actually put together a system on their own. So we'll start talking about that. Grow spaces, we did talk a little bit about that today, about grow tents, but we'll also talk about converting bedrooms and basements into grow spaces, and also we'll be talking more about fans and ventilation and some other technology involved in putting together interior grow spaces. So hopefully this has been helpful. If it has been helpful, please do me a favor. Give a like and a subscribe to the channel. Help other people to find this information. Tell your friends, tell your colleagues, tell your pets, tell anybody who will listen that this is the place to go if you want to learn about hydroponics. Thank you for watching. I'm going to see you next week. And I've got a week to figure out all these other cameras and all this other cool stuff that I'm about to use in these productions. So thank you for tuning in. Thank you for joining the revolution in indoor growing. Thank you for trusting Aero-Gro. We'll see you next time.